everyone. Let's try to solve this geometry problem. Now we're given four equal squares, each with an area of 4 square units that is inside a circle. Now we're going to find the area of the circle. So remember that every time we're going to find the area of a circle, we always need a measure for the radius. But since in the given problem, we don't have the measure for the radius, we need to draw auxiliary lines in order for us to find its measure. And one of such auxiliary lines is a radius drawn from this point intersecting chord YZ in a perpendicular manner. So let's go ahead and do that. You now have this one. So again, this red segment, which is the radius, is perpendicular to chord YZ. Now we need to find the measure of this segment. Remember that one square has an area of 4 square units. That means one of the sides measures 2 units. So that's why you have 2 here. This is also a side of a square having an area of 4 square units. This is also 2. And since this part is equal to this part, and this part is equal to this part, then both of them will measure 2 units as well. Now you notice that we still have this small segment here, this one. So we don't have the measure, so let's just label it as A. Then we need to find the measure of this part here. Take note that this radius here is perpendicular to chord YZ. So you now have a radius intersecting a chord in a perpendicular manner. We'll now go to a particular theorem which is called the radius chord perpendicularity theorem, which states that if the radius of the circle is perpendicular to the chord, then it bisects the chord. Since this radius here, marked in red, intersects chord YZ in such a way that it is perpendicular, therefore it bisects YZ, meaning it divides the measure of YZ into 2 equal smaller measures. Since YZ is a side of a square and the side of a square is measuring 2 units, and since this is bisected, therefore each part, each small segment will have a measure of 1 unit. Next, we need to draw another auxiliary line from the center going to point Z, and that is also a radius. We name it as R. Now, we consider this triangle, this one here. So this red part has measures 2, 2, and A. So you have this one, and the green one has 1 unit, and then the blue one is R. This is your hypotenuse. We can now use the Pythagorean theorem to solve for that one. You have now 4 plus A quantity squared plus 1 squared equals R squared. We simplify this. This will become 17 plus 8A plus A squared equals R squared. Next, we draw another radius from the center going to point X. So you have that one, the black segment. So this is still R because again, that is radius. Then we draw this chord from point X and another radius perpendicular to this chord here. So you now have a triangle. Let's find the measures of the sides of this triangle. This one here is a side of a square, so this is 2 units. And this here is 2 units. But here, this 2 is equal. But take note that this yellow segment is not equal to the 2 units because there's a portion there that's not been taken by the yellow segment. And this part here, if you draw that here, this will be the same length as A. That means the yellow segment can be taken if we break the 2 into two segments and take away the a, that's why this one is 2 minus a. And since this one is equal to this will also be 2 minus a. And then for this part here, since this is a side of a square, 2 units, that's equal, so this is also 2. Then these three here, this one, are just equal, which is 1 unit. Therefore, this is also 1 unit. Now, we consider this triangle here. This is another right triangle. The sides, the green one have sides of 2 minus a and 2. So that is 4 minus a. That's 4 minus a. And then 2 and 1, that's 3. And then r. So we solve for that. Solve for the radius using the Pythagorean theorem. This is now 4 minus a squared plus 3 squared equals r squared. Simplify, that will give you 16 minus 8a plus 9 equals r squared. Then, both equations, as you notice, is solved for r, so we can combine the two equations. So we still simplify this one first further. 16 plus 9 equals 25 minus 8a plus a squared equals r squared. Now again, these two equations now are solved in terms of r, so we can combine both equations now. We have 17 plus 8a plus a squared equals r squared, and 25 minus 8a plus a squared equals r squared. We equate both equations because both equations are solved in terms of r. Now in this equation, we can cancel the a squared. We can combine the 8a in one side and then transpose the 17 to the other side. That will give us 17 plus 8a equals 25 minus 8a. Simplify, that gives us 16a equals 8. Solve for a is equals to 1/2. Now, to solve for the radius, we can use any of the two equations that we had before, any of these two, but let's just choose this one. Substitute the value of a to the equation. You now have r squared equals 17 plus 8 times 1/2 plus 1/2 squared. R squared equals 17 plus 4 plus 1/4. You now have r squared equals 21 plus 1/4. That gives you 85 over 4. Now, since we're finding for the area of the square, remember, that is given by our area of a circle is equals to pi r squared. We don't need to solve for the r. We directly substitute this to the formula for the area of the circle, which is pi r squared. You now have pi times 85 over 4. Simplify this. That will give you 85 pi over 4. Therefore, the area of our circle is equals to 85 pi over 4. And the problem is solved. So thank you so much for watching this video. Please subscribe to our channel for more exciting geometry problems. Thank you so much. Enjoy learning.